Hello everyone. The topic of objects and references is tricky, so we'll be spending a lot of time in today's lecture reviewing the materials that we covered as part of the previous lecture. We're going to get today's lecture started by going through a mini quiz. Please pause the lecture video here and provide your answers to these questions as a comment in the comment section. Question A is asking, what do variables contain? Recall that variables contain references to objects and not objects directly. Question B is asking, how should we label the blanks in the hierarchy? There are two black nodes which contain blanks as part of the hierarchy diagram on the right hand side, and you are expected to place name tuple and tuple within those blanks. Recall that name tuple enables you to create custom types which are immutable. So if you want to create custom types like person and hurricane, you want to use name tuple and not tuple. Also recall that you cannot create object instances directly from name tuple. You should rather create custom types from name tuple and use those custom types to instantiate objects. Tuple, on the other hand, allows you to instantiate objects directly. Question C is asking which of the following live inside frames. Recall that variables live inside frames and that variables in frames reside in stack memory. Objects, on the other hand, reside in heap memory. In today's lecture, we'll be learning how to create copies of objects. We are going to learn about three different types of copying. Those are reference copy, shallow copy, and deep copy. We'll be learning the definition for the term depth. Depth is nothing but how deep a particular object is from the reference. In other terms, how many arrows does it take for you to reach a particular object from the reference? The reading for this particular material is chapter 4 of Swigart book. Let's get today's lecture started by going through problem number 1 from worksheet. Please pause the lecture video here and download today's lecture worksheet. I've already downloaded the docx version. We are going to fill in this particular table. The columns of the table represent various features about types, and each row contains a particular type that we have covered. We are going to fill in true or false values depending on that particular feature. The first feature that we are going to discuss is mutability. Recall that lists and record class are mutable. Tuple and name tuple, on the other hand, are immutable, meaning that you cannot change the values within those types. Lists and record class, on the other hand, allow you to change values, hence they are mutable. What is meant by pre-installed? When you have to execute pip install command to install a particular module, that particular module is not pre-installed. Recall that list tuple and name tuple are all available to us without any kind of pip install command execution. So I'm going to put in true for the first three rows here. Record class is not pre-installed because we had to execute pip install record class command. Let's go through the next feature here, which is asking which of these types are built-in. Recall that built-ins are types which do not require any kind of imports. So you can use list and tuple without importing anything within your program. So those are going to be built-in types. Name tuple, on the other hand, requires you to import name tuple from collections module. So I'm going to mention that name tuple is not a built-in. Record class clearly is not a built-in because you had to even install that particular module. You will have to say from record class, import record class to be able to use record class. Let's talk about which of these types allow you to create new types. Lists and tuple do not allow you to create new types, so I'm going to type in false there. Name tuple and record class, on the other hand, allow you to create custom types. Recall that name tuple allows you to create immutable custom types. You can remember that by remembering that name tuple has been named after tuple. Tuple is immutable. Record class also allows you to create custom types, but those types are going to be immutable. Let's talk about the last feature, which is named attribute. I'm going to first give you an example here. Let's say that we have a reference variable A. You're trying to say A of 0 where you mention of 0 within square brackets. This implies that this particular reference variable is storing a reference to either a list object or a tuple object. What would be the case if I were to say a.name? That's going to be when the variable a is storing a reference to an object which was instantiated from a custom type created by name tuple or record class. So for the last column, we are going to fill in false for the first two rows because neither list objects nor tuple objects have named attributes. Custom types created by name tuple and record class do have named attributes. Let me switch back to the slide deck. We will come back to going through problems 2, 3, 6 shortly. Once I switch to the slide decks, we are going to review what exactly assignment operation does. Recall that assignment operation creates a copy of the reference and not the copy of the object itself. I'm creating a list object here which contains three string items as A, B, and C, and I'm adding a reference to that particular list object into the variable x. Then I'm saying y equal to x. This implies that y should reference whatever is being referenced by x. If we were to draw the diagram from mental model version v2 for state, we'll draw the variable box beside x and add an arrow from that to the list object here. Similarly, we'll draw an arrow from the variable y's box to the exact same list object. That's because assignment operation does not create copy of objects. What this particular snippet of code does not do is the second option here, where you have a reference from the x variable to the list object and you have a reference from the y variable to another list object. In today's lecture, we learn how to do this second option by means of creating copies for objects. You can never achieve this third possible diagrammatic representation in Python. You cannot make a variable reference another variable. That doesn't make any sense. Let's talk about the function argument passing. I'm going to modify this particular example slightly. I'm going to define a function called f, which includes a parameter y. Outside, I'm creating a list object within the global frame whose reference is included inside the variable x here. Then I'm passing x as argument to the function f. Recall that whenever you're making a function call, your parameter variable should reference whatever is being referenced by the argument variable. If you were to update the diagrammatic representation to correctly reflect that we have two different frames, you'll mention the variable x box within the global frame, and within the function f frame, you'll mention the variable y's box. Both of those are going to include references to this exact same list object here. Let's go through review examples to understand assignment operation and argument passing. I'm going to go through each of these examples using Python tutor session. I'm going to switch to the course website, click on tools, Python tutor, and I'll be clicking on live program mode. Let me paste the example that I copied, and we are going to step through from the beginning here. The first line is creating an empty dictionary object and adding a reference for that into the variable x here. So that's going to get displayed as part of the global frame in the visualization. Line number 2 is saying y equal to x. That's only going to create a reference copy. So you're going to have an arrow from the y variable box to the same empty dictionary object. Line number 3 says y of some key equal to some value. Recall that when it comes to dictionaries, you can insert a non-existent key's value by simply specifying y of key equal to value. So this is going to add the key Wisconsin string and the value Madison string as part of this particular dictionary object. Then in line number 4, we are invoking the print function to display x of Wisconsin key, even though we did not directly make any modifications to the reference inside the variable x, that is still going to display Madison. That's because both x and y variables contain reference to the same dictionary object here. Let me switch to the slide deck and we are going to go through example number 2. Example number 2 is going to make us define a function foo, stepping through from the first. The first line of code that will get executed is this particular list object instantiation. We are going to create a list object which contains two integer items as 1 and 2, and we'll be adding a reference to that particular list object into the variable items, which will be part of the global frame here. Line number 5 is using the assignment operation to create a reference copy. So numbers is now going to reference whatever is being referenced by items, which is this particular list object here. Then we are invoking the foo function by passing numbers as argument. That's going to make nums within the foo function call frame reference whatever is being referenced by numbers and items. So right now we have three different references to this exact same list object here. If I click on next, that's going to execute line number 2. Recall that the append method impacts the original object when it comes to list sequences. So when you say nums.append of 3, that's going to add the item 3 at index position 2 within the original list object here. So if we display nums in line number 3, that's going to display all three items. Now when I click on next, even though the function call frame for foo gets deleted, you still have references which are part of the global frame to this particular list object, so that list object will not get deleted. So when we display items in line number 7 and numbers in line number 8, you're going to get the exact same output as line number 3. That's because we modified the original list object here. Recall that the concatenation plus operator behaves very differently than the append method call for list. If I were to say nums equal to nums plus a new list containing this integer object 3, that would give you a totally different output from this program. The program would output 1, 2, and 3 from line number 3, whereas in line number 7 and 8, you're only going to see 1 and 2. That's because the plus concatenation operator creates a brand new list object. Once again, recall that the plus equal to syntactic sugar operator works very differently. It behaves just like the append method call and does not behave like the plus concatenation operator. Let me switch to the slide deck and we are going to go through example number 3 here. Example number 3 is containing a slicing line of code. First line of code here is creating a list object which contains the strings AAA and BBB. I'm adding a reference to that particular list object into the variable X. Then in line number 2, I'm saying that give me a slice from X. How do I know this is a slice? Observe that we have a colon within the square brackets. If you have a colon, you have slicing. If you have a comma, then you're defining a list. If you neither have a comma nor a colon, then you're using indexing. Whenever you're slicing, your start and the end index are completely optional. So if I were to skip both the start and the end, I'm saying that give me a copy of the original list. Whenever you slice a sequence, you're going to get a brand new object of the same sequence type. So this particular line is going to create a new list object and add a reference to that particular list object within the variable y here. Line number 3 is calling the pop method call. Recall that the pop method takes an index position as argument and removes that particular item at that index position and returns that value. So if I were to execute x dot pop of 0 here, that's going to remove the item string triple A, and you're going to only have the item triple B as part of the list object which is being referenced by the variable x here. This will not have any kind of impact on the other list object because slicing creates a brand new list object. So line number 4 print function call here will display a value of 2, which is going to be the length of the list object, which is referenced by the variable y here. Slicing again is an exception which you need to keep in mind. Just like concatenation operator creates brand new object, slicing also creates brand new object. I'll wrap up this video here. In the next video, I'll be covering problems 2 to 6 from today's lecture worksheet.